Create a basic program using Bertrand teaching pattern to realize the TCP movement track of robot tool as shown in the figure. The programs in Bertrand's software system are divided into 4 types: basic program, process package, function package, and modular program. Among them, the other 3 types will eventually be converted into basic programs to be compiled and executed by the MIG controller. Before creating the basic program, you should firstly set setup safety zone and zero safety zone. Secondly, create the tool coordinate system and the user coordinate system. Thirdly, create the welding process package. Fourthly, carry out the code path planning. Step 1. Create a new basic program. Click the blank box of the program name on the touch screen. A soft keyboard will appear. Enter the program name and then click New. Step 2. Teach manually and then add code instruction. A code instruction runs in the robot system, which is expressed as a moving track that controls the robot from the start point to the end point. In this instruction, you need to specify the movement type, run-to point, speed, and smoothing ratio. Movement type. Movement type is to select the track, including joint movement, linear movement, arc movement, and circular movement. Run-to point. The running track of the program is connected by the start point and the end point of each curve in the program. The end point of each curve is the start point of the next curve. Therefore, while using the curve instruction, you only need to set the end point of the curve through manual teaching, that is, the run-to point. You should manually teach the tool TCP to point T1, connect the run-to point text box, change the point name to T1, select the tool coordinate system name, read the current point date, confirm, and save. Then you should specify the movement speed of the robot and set the smoothing ratio of the track. Click the Add button and an instruction will be added in the program instruction area. During manual teaching of the run-to point, when the robot TCP is far from the target point, it can use a large teaching speed and long press the operation key to move the robot arm. When the robot TCP approaches the target point, use a small teaching speed and press the operation key to control the macro movement of the robot. The final program is shown in the figure. Pay attention here. When the program is running circularly, after the last curve instruction is completed, the robot will continue to run the first curve instruction with the run-to point of the last curve instruction at the start point to form a closed motion loop.